Hello, welcome to Chimney Sweep University Training Series. Today's 1-hour lesson will focus on Chapter 8 through 13 of NFPA 211. If this is a free version, then interactive questions, quizzing, and answers will be turned off. If this is a paid version for continuing education unit or certification requirements, then you will be in a full interactive version. For information of where to sign up for the premium version, go to chimneysweeps.com and find the section regarding training. Good luck, and enjoy your presentation.
All right, ready to get into it. We're taking a deep dive today, talking chimneys and vent connectors.
Oh, yeah, the essential but often overlooked parts.
Exactly.
Yeah.
Specifically for those solid fuel-burning appliances, the wood stoves and fireplaces that add that, cozy rustic charm.
Yeah, absolutely.
But we're not just talking aesthetics here, folks. We're diving deep into safety. We're going to unpack chapters 8 and 9 from the NFPA 211 standard, which is basically like the Bible for making sure these systems are set up right.
The ultimate rule book.
Exactly. And think of it this way. We're distilling those sometimes dense guidelines into a digestible format so you can feel confident about safety, best practices, all that good stuff.
Right, because let's be honest, it's easy to skim over those details when you're picturing that roaring fire.
Oh, yeah, for sure. But these chapters really drive home why understanding the specifics is so crucial, to protect your home and your family.
Absolutely, yeah.
So we're talking chimney height, clearances, even this thing called a thimble, which we'll get to later. Those details that might not seem super exciting at first glance.
And make your eyes glaze over a bit.
Exactly. But they actually have huge implications, right, when it comes to safety and efficiency.
Yeah, and what I find fascinating is how those seemingly mundane construction details really tie into those critical safety considerations.
It's all connected.
It is, yeah. It's a great reminder that every element of a chimney system serves a purpose.
All right, so Chapter 8, let's kick things off there. This one focuses on unlisted metal chimneys. So I'm picturing like those classic smokestacks you see on older homes.
Yeah.
What makes these chimneys special? Why do they get their own chapter in the rule book?
Well, they're called unlisted because they're not covered by like specific product listings. So think of them like custom builds.
Oh, okay, so not prefab.
Right. And because they're not pre-engineered, tested as a complete unit, there's a greater need for attention to detail during installation. Got to make sure everything's just right.
So it's kind of like having a tailor-made suit, right? You need those precise measurements for everything to fit and function the way it should.
Exactly. And one of the most important measurements is the chimney's height. Chapter 8 specifies that these unlisted metal chimneys for residential or low-heat appliances got to extend at least 3 feet above the roof.
Okay.
And be 2 feet taller than any part of the building within 10 feet.
Okay, now that sounds super specific. It's not just about the chimney's height, but what's around it too, right?
Right. Yeah.
Is that just about aesthetics, or is there a safety reason behind this 2 feet taller rule?
It's all about preventing downdrafts.
Okay.
Wind can create these pockets of low pressure around your house, right?
Yeah.
So if your chimney's not tall enough, those low pressure zones can basically suck the smoke and gases back down the chimney and into your home.
Yikes. So it's like a reverse vacuum cleaner effect?
Exactly. Instead of sucking the smoke out, it's pulling it back in.
Not good.
Not good. And that's why the standard is so precise about that 2-foot clearance.
Sure.
It's creating that safety buffer, ensuring that even with wind swirling around, the smoke and gases have a clear path upwards.
Right. So let's say, hypothetically, I have a dormer window near my chimney.
Okay.
Does that mean I need to make my chimney like even taller to clear the dormer by those 2 feet?
Yeah, that's a great question. And the answer is yes. Any part of your building within that 10-foot radius needs to be considered when you're calculating your chimney height. It's like creating this invisible dome around your chimney, ensuring nothing obstructs that upward flow.
So it's like a 3D chess game almost, figuring out how to position that chimney strategically.
Yeah, you got it.
Okay. And Chapter 8 doesn't stop there.
Yeah.
Right. It also gets into clearance requirements, both inside and outside your house, for those unlisted metal chimneys. It's not just about preventing fires, but also ensuring proper airflow, heat dissipation.
Absolutely, yeah. Don't want your chimney turning into a giant space heater.
Exactly, scorching everything around it. But what about those situations where the chimney has to pass through a a combustible roof. I'm picturing like a wooden roof deck.
Mm-hmm.
That just seems like a fire hazard waiting to happen.
Well, that's where the thimble comes in. Chapter 8 really highlights this crucial component. And figure 8.2.2.7 actually provides a great visual representation. Think of it as like a protective shield for your roof.
Okay, I'm intrigued. What exactly is a thimble? And how does it work? It's magic.
So it's basically a section of pipe, usually made of galvanized steel or another heat-resistant metal, and it creates an air gap between the hot chimney and the combustible roof. It acts as that barrier, reducing the heat transfer, preventing the roof from getting too hot.
So it's like a buffer zone, keeping the heat where it belongs and the roof safe from harm.
Exactly. And the standard goes into, detail about how to construct and install this thimble properly. It specifies the minimum thickness of the metal, how far it needs to extend above and below the roof, even the type of fasteners you should use.
Wow, there's a lot more to it than I imagined. It's like a tiny but mighty piece of engineering protecting your home from potential fire hazards.
It is, yeah. And it just goes to show how seemingly small details can have a huge impact on safety. That's why understanding these standards is so important. They provide that roadmap for ensuring your solid fuel-burning appliance is installed and operated safely, protecting both your home and your family.
Makes perfect sense. All right, so you've covered some good ground with Chapter 8, getting a handle on those unlisted metal chimneys. But let's turn our attention now to Chapter 9, chimney connectors.
Okay.
These are the unsung heroes that bridge the gap between your appliance and the chimney itself, right?
Yeah.
And Chapter 9, it dives deep into the world of connectors, emphasizing the importance of using the correct materials and ensuring proper installation. Okay, I'm ready to dive deeper into the connector conundrum.
Yeah.
Let's start with the materials themselves. I'm guessing not all metal pipes are created equal when it comes to handling the heat and fumes from a roaring fire.
You're absolutely right. Chapter 9 outlines the different types of chimney and vent connectors, and it highlights which materials are suitable for different types of appliances and installations. It's kind of like a matchmaking service,
Okay.
pairing the right connector with the right appliance.
All right, so let's break down this connector lineup. What are some of the key players we need to be familiar with?
Well, first up, you have your single-wall metal pipe connectors,
Okay.
typically made from materials like stainless steel and black steel. They're pretty straightforward, just a single layer of metal designed to handle those exhaust gases.
And these single wall connectors are commonly used for.
You'll often find them connecting wood stoves or fireplaces to their chimneys, especially in situations where, maintaining adequate clearances from combustibles isn't an issue.
Okay, so shorter runs, plenty of space around the connector. What about those situations where you might need a bit more protection? Say if you're running the connector through an enclosed space.
That's where double wall connectors come in.
Okay.
They offer a step up in terms of safety and insulation,
What?
with an inner layer of stainless steel to handle the heat, and an outer layer, usually galvanized steel, for added protection.
So it's like a built-in jacket for your chimney connector, keeping things cool and collected on the outside. But what's in between those layers?
That's the secret sauce. The space between those layers is filled with a non-combustible insulating material, typically ceramic fiber. It acts as a thermal barrier, reducing the surface temperature of the connector and minimizing the risk of nearby materials getting too hot.
So it's like a personal bodyguard for your chimney connector, deflecting that intense heat.
Exactly.
So double wall connectors seem like the go-to choice when you need that extra layer of protection, especially in those tight spaces.
Absolutely. They offer peace of mind and greater flexibility in terms of installation. But let's not forget about our gas-powered friends. Chapter 9 also mentions Type B and Type L vent materials, which are specifically designed for venting gas appliances.
So it's a whole different ball game when it comes to venting gas appliances.
It is, yeah.
Why are these materials different from those used for solid fuels?
It all comes down to the combustion byproducts.
Okay.
Gas appliances produce different types of gases than solid fuels, and the venting materials need to be compatible with those specific gases. Type B is typically used for appliances with draft hoods, while Type L is for appliances without draft hoods.
So it's like having specialized exhaust systems for for different types of engines,
Yeah.
right? You need the right system to handle those specific emissions.
Exactly.
So we've got single wall, double wall, type B, type L. Seems like there's a connector for every occasion.
That's right. But choosing the right connector is only half the battle.
Right.
Chapter 9 also dives deep into the nitty-gritty of metal thickness requirements for steel pipe connectors.
Okay.
It provides a handy table, Table 9.2.2.3, that outlines the minimum thickness required for different situations.
Okay. Bring on the metal thickness mysteries.
Yeah.
What factors determine how thick that steel needs to be?
Well, it's a balancing act,
Okay.
influenced by several key factors. First, you have the type of appliance. Residential appliances like your typical wood stove or fireplace usually require a minimum thickness of 24 gauge steel.
Now I'm picturing a standard sheet of paper is 24 gauge thinner than that.
You got it.
Why?
It's thinner than paper, but remember this is steel, so even a thin sheet is incredibly strong.
Okay, so it's thin but mighty. But I'm guessing there are situations where you might need a thicker gauge, right?
Absolutely. If you're dealing with higher temperatures, larger diameter pipes, or heavier duty appliances, you'll need to bump up the thickness to handle the increased stress.
So it's all about matching the thickness of the steel to the demands of the situation. Now, what about the distinction between single wall and double wall connectors? Does that play a role in the thickness requirements?
It does. That insulating layer in a double wall connector acts as a shield, allowing you to use a thinner gauge of steel compared to a single wall connector for the same application.
Ah, so the double wall design gives you a little bit more wiggle room when it comes to metal thickness. It's like having a built-in safety net that allows you to use a lighter material.
Exactly. It's another advantage of using double wall connectors. They offer greater flexibility in terms of both installation and material selection.
This is fascinating. It's like a puzzle where all the pieces have to fit together perfectly. The type of appliance, the type of connector, the thickness of the steel. Seems like you really need to do your homework to get it right.
You do, and that's where the standard comes in, right? It provides that roadmap, ensuring you're making informed decisions about every aspect of your chimney and vent connector system.
All right, we've covered some important ground today, exploring those intricacies of chimney and vent connectors. We've decoded those unlisted metal chimneys in Chapter 8 and delved into the world of connector types and metal thickness requirements in Chapter 9.
It's a reminder that even those seemingly mundane details can have a huge impact on safety.
Exactly. But we've only just scratched the surface of Chapter 9. There's a lot more to unpack when it comes to clearances, installation techniques, and testing procedures.
We've got a lot more ground to cover.
Exactly. We'll be right back to dive deeper into those crucial details.
So picking up where we left off, let's dig a little deeper into those clearance requirements outlined in Chapter 9.
Okay, yeah, clearances. It seems like they're kind of a recurring theme in these chapters, and for good reason, I imagine.
Absolutely. Clearances to combustibles, as they're called, refer to the minimum distance a chimney connector or any part of the venting system really has to be kept from anything that could, well, catch fire.
Right, of course, yeah. Makes sense.
Like wood framing, insulation, even furniture in some cases.
So it's about creating that safety zone around those hot components, making sure that heat doesn't transfer to nearby materials and potentially, ignite them.
Exactly. And the standard, it isn't messing around when it comes to those distances. Table 9.5.1.1, it lays out those minimum clearances in black and white, specifying the distance required for different types of appliances and connectors.
All right, so let's say, hypothetically, I'm installing a single-wall metal pipe connector for my trusty wood stove. What kind of clearance am I looking at there?
For a single wall connector like that, you'd need a clearance of at least 18 inches from any combustible material.
18 inches. That's pretty significant. That's wider than my hand span.
It is, and improper clearances, they're a major contributing factor to house fires. So those measurements are there to protect your home and your family.
Now, what if you're in a situation where you just, you simply don't have that much space? Are you just out of luck, or are there ways to kind of work around those minimum clearances?
There are ways to reduce those clearances, but it has to be done very carefully and in accordance with the standard, of course.
Right.
Chapter 9 outlines several methods, but they all involve adding layers of protection to those combustible materials.
Okay, so it's not just about like squeezing things in. You need to actually take steps to manage that heat transfer no matter what. What are some examples of these protective measures?
One common method is using a non-combustible wall shield.
Okay.
Often made from a material like cement board. It acts as a heat barrier, preventing the combustible material behind it from getting too hot.
So it's like adding a layer of armor to that wall or ceiling.
Exactly. Another approach is creating an air gap using ventilated metal spacers. This allows for air circulation, keeping those combustible materials cooler.
It's all about creating those buffer zones, preventing the heat from building up in the wrong places. Now, we talked earlier about those double wall connectors with their built-in insulation. I'm guessing those impact clearance requirements as well, right?
You got it. That extra insulation in a double wall connector, it allows for smaller clearance requirements compared to single wall connectors. So that 18-inch clearance we mentioned for a single wall connector, that might be reduced to 6 inches if you're using a double wall connector.
That's a significant difference. It seems like choosing the right connector can really open up possibilities in terms of installation flexibility.
Absolutely. It's one of the many benefits of double wall connectors. They offer enhanced safety, greater flexibility, and often better performance overall.
Okay, so clearance is check. We're starting to get a handle on those spatial considerations. But let's move on now to the actual installation process itself. Chapter 9 really emphasizes the importance of proper installation techniques. What are some key things to keep in mind when connecting those pipes and fittings?
Well, installation is just as critical as choosing the right materials. You know, even the highest quality connector won't perform safely if it's not installed correctly. It's like having all the right ingredients for a cake, but not knowing how to bake it.
Exactly. You could have the perfect recipe for disaster if you're not careful.
Right. One fundamental aspect is proper support. Chimney connectors, they need to be adequately supported along their entire length to prevent any sagging or movement.
So it's not just about connecting the pieces. You need to make sure those connections are solid and secure.
Precisely. Sagging or movement can put stress on the joints, leading to leaks or even structural failure. The standard provides recommendations for support spacing, typically around 3 to 4 feet.
Oh, yeah.
You know, using metal straps or brackets to secure the connector to framing or structural elements.
It's like building a scaffold for your chimney connector, making sure it's held in place and can withstand those forces. Now, what about those situations where the connector has to pass through a wall or a ceiling? Those seem like tricky spots.
They can be, but Chapter 9 offers guidance for those wall and ceiling penetrations. It highlights the importance of maintaining those clearances and using appropriate fire-stopping materials.
Fire-stopping, that sounds serious.
It is. Think of it as creating a firewall around that penetration point.
Okay.
It involves using non-combustible materials to seal any gaps or openings around the connector, preventing the spread of fire in case of overheating. The standard it gets very specific about the types of fire-stopping materials and installation methods that can be used.
So it's like adding an extra layer of protection, making sure that even if something goes wrong, the fire is contained.
Yeah.
Now, what about those scenarios where the connector has to make a turn or a bend?
Bends and turns, they're unavoidable sometimes, but they can create stress points in the system. Chapter 9 stresses the importance of using proper fittings and support methods to maintain the structural integrity of those bends.
So you can't just bend a single wall connector.
Yeah.
To fit. You need to use the right components and techniques.
Exactly, and the number and severity of those bends can also impact the draft of the system, potentially affecting how well the smoke and gases flow up the chimney.
So it's all about maintaining that smooth and efficient pathway for the exhaust, making sure everything is flowing in the right direction.
That's the goal. Now, we've talked about supporting the connector along its length and navigating those bends and turns. But what about the connection points themselves, where the connector meets the appliance and the chimney?
Yeah, those seem like critical junctures, literally.
They are. These connections, they need to be airtight to prevent any leaks, which could allow dangerous gases to escape into your living space. Chapter 9, it emphasizes the use of high temperature sealants and gaskets to create a tight and durable seal.
So it's like creating a closed system, making sure those combustion byproducts stay contained within those pipes and don't sneak out into your home.
Precisely. And while we've, covered a lot of ground on installation techniques, I want to emphasize that this is just a high-level overview. The NFPA 211 standard, it goes into much greater detail, and it's crucial to consult the standard and work with qualified professionals.
It's a reminder that this isn't a DIY project for the inexperienced. Installing these systems properly requires a deep understanding of those guidelines and a commitment to following them carefully.
Absolutely. We're dealing with the power of fire here, and it's essential to treat it with respect and take every precaution to harness it safely and responsibly.
Well said. So we've tackled clearances, installation techniques.
Right.
What's next on our Chapter 9 checklist?
Testing. After all that meticulous planning and installation, Chapter 9 emphasizes the importance of testing the system, to ensure that everything's functioning as intended.
Okay, so now we get to put our work to the test.
Exactly. And this testing, it provides peace of mind, confirming that your system is safe and efficient.
Okay, so testing. After all that planning and installation, it's time to see if it all works. I have to admit, I'm picturing like smoke bombs and pressure gauges.
Yeah, it's not quite that dramatic, but it is a crucial step, like the final inspection before you give your chimney system the green light.
So walk us through. What does this testing process actually involve?
Well, it starts with a thorough visual inspection
Okay.
of the entire system, from the appliance connection to the chimney cap. You're looking for any signs of leaks, gaps, obstructions, anything that seems amiss.
So eyes peeled for any potential trouble spots.
Yeah,
A keen eye for detail probably comes in handy here.
absolutely. You want to make sure everything is properly connected, sealed, and supported. Then, depending on the type of system, a draft test might be performed.
Okay.
This involves assessing the airflow through the chimney, making sure it's drawing properly.
Ah, the draft. We talked about downdrafts earlier and how important chimney height is for preventing those.
Yeah.
Is this draft test checking for similar issues?
Exactly. A properly functioning chimney relies on a good draft to pull those combustion byproducts up and out of your home.
Right.
The draft test helps identify any issues that might hinder that flow, things like obstructions, leaks, or even negative pressure in the house.
So it's not just about keeping the smoke and gases ODT of the house, but also making sure they have a clear path to escape.
Right.
What happens if the draft test reveals a problem?
Well, that's a sign that something needs to be addressed. Could be a simple fix like removing an obstruction or sealing a leaky joint, but sometimes it might indicate a more complex issue requiring adjustments to the chimney system itself.
This really highlights the importance of having a qualified or professional conduct these tests.
Mm-hmm.
They have the knowledge and experience to diagnose and troubleshoot any problems that might come up.
Yeah, absolutely. They can interpret the results of the tests, pinpoint the source of any issues, and recommend the appropriate solutions.
The NFPA 211 standard breaks down vents into different types.
It does.
Type B, B, W,
Yeah.
and L.
Right.
Can you walk us through what makes each of these unique?
Yeah, absolutely. So you can think about it this way. Each type of vent is designed with a specific fuel source and appliance in mind. So if we start with like type B vents, right?
Yeah.
These are your workhorse for gas appliances that have draft hoods, as well as any category appliance that needs a type B vent. Usually they're made from galvanized steel, aluminum, or stainless steel. Tough materials for those hot gases.
Okay, interesting. So it's about making sure those combustion gases are safely and efficiently vented to the outside.
Exactly.
What about type BW vents?
These are kind of like the specialists
Oh.
designed for vented gas wall furnaces. So like if you see one of those units mounted high up on a wall.
Yeah, so if I have one of those wall-mounted gas heaters, I'd need a Type BW vent.
Exactly.
Got it. Now, what about Type L vents? Those seem a bit more versatile from what I've read.
Yeah, you're right. Type L vents can be used for both oil and gas appliances.
Okay.
And here's a key difference. Type L vents are made from factory-built components. This ensures a higher level of quality control and standardization. Big plus for safety and performance.
Oh, that makes sense.
Right.
Okay, so we've got our different types of vents, each designed for specific purposes.
Yep.
But how did these things actually get installed?
Well, this is where things can get tricky, and the NFPA standard goes into a lot of detail to make sure it's done right. But regardless of the vent type, proper sizing is critical.
Okay.
The vent needs to be the right size for the appliance to ensure those combustion gases are removed effectively and safely.
It's like making sure you have the right size pipe for your plumbing.
Exactly. You got it.
Yeah.
And then you have to think about clearances.
Right.
How far the vent needs to be from things that could catch fire. The standard has a whole table, actually. Table 9.5.1.1.
Oh, wow.
With incredibly specific measurements for these clearances.
I'm guessing that's to prevent the heat from the vent transferring to nearby materials like wood framing or insulation.
Yeah.
It's all about preventing fires.
Right.
You got it.
Yeah.
It's like having that safety zone around a campfire.
Yeah.
You don't want anything flammable getting too close.
Right.
And it's not just about keeping things far enough away. When the vent passes through a wall or a roof, it needs to be done with specific materials and techniques to maintain that fire safety barrier. So no cutting corners there.
No cutting corners. And I know you were particularly interested in dryer vents.
Yeah.
So let's dive into those next. They have their own set of rules and guidelines in the NFPA standard.
Perfect, because that's what I was hoping we'd get to.
Right. Let's do it. Yeah, dryer vents, they seem simple enough, right?
Yeah.
But they're often a source of trouble.
Oh, really?
Because people don't realize how many specific regulations actually apply to them.
So let's break it down. What are the biggest things people need to know about dryer vent installation
Yes.
according to this NFPA standard?
Okay, so first off, length matters.
Okay.
The maximum length for a dryer vent is 35 feet. But that's assuming a perfectly straight run.
Right.
And how often does that actually happen in real life, right?
Yeah.
Any bend you add reduces that allowable length.
Oh, wow.
Yeah, so a 45-degree bend knocks off 2.5 feet,
Okay.
and a 90-degree bend
Oh, my gosh.
takes off a full 5 feet.
Wow. So a few twists and turns, and you've really eaten into that maximum like that.
Yeah, you really can.
It makes me wonder if my own dryer vent is even up to code.
You know, it's worth checking.
Yeah.
And while you're at it, take a look at the material.
Okay.
The NFPA standard is very clear. It has to be rigid metal or another non-combustible material.
I'm guessing that rules out the flimsy foil ducts I sometimes see at the hardware store.
Yeah, those flexible ducts might be tempting because they're easy to work with,
Yeah?
but they can be a real fire hazard. They can sag, they can trap lint, and they're just not as durable as rigid metal.
Okay.
Plus, they need to have a smooth interior surface
Right.
to minimize lint buildup.
Right.
Those foil ducts just don't cut it.
So smooth metal duct it is. I've also heard some horror stories about dryer vent fires.
Yeah.
Is that really a common problem?
And unfortunately, yes. Dryer vent fires are more common than you think.
Really?
And they're often caused by improper installation or materials. Lint is extremely flammable.
Yeah.
And when it builds up in a vent that isn't properly sized, installed, or maintained, it creates the perfect conditions for a fire.
Okay, that's enough to make me want to go home and check my own dryer vent right now.
Yeah, you really should.
So let me make sure I've got this straight. Maximum 35 feet,
Right.
minus any deductions for bends,
Kurt.
rigid metal duct with a smooth interior.
Yes.
Anything else?
Yeah. One more crucial point. Your dryer vent should never, ever be connected to any other vent or chimney.
Okay.
It needs its own dedicated path to the outside.
Yeah, that makes sense.
Yeah.
So we've talked about the different types of vents, the importance of proper installation,
Mm-hmm.
but what happens if things aren't done right? What are some of the red flags that might indicate a problem with a venting system?
Oh, that's a great question. One of the most obvious signs is a decrease in appliance performance.
Okay.
Like if your dryer is taking forever to dry clothes,
Right.
or your gas fireplace isn't producing as much heat as it used to,
Yeah.
that could be a sign that the vent isn't doing its job properly.
So it's all about paying attention to how the appliance is behaving.
Exactly. And keep an eye out for visual cues as well. Soot or smoke inside your home, major red flag. Yeah. Means those combustion gases aren't being vented properly.
Right.
They're leaking back into your living space.
That sounds pretty scary.
Yeah, it's not good.
And probably not great for your health either.
Definitely not. You also might notice unusual odors.
Okay.
So a strong smell of gas or exhaust fumes is another sign that something's amiss with your venting system.
I can imagine that would be pretty alarming.
It is.
Anything else?
Listen for any unusual sounds coming from your vent,
Okay.
like rattling or whistling.
Interesting.
Those noises can indicate blockages, loose connections, or other problems that need attention.
So we're talking about performance issues, visual cues, odors, and sounds,
Mhm.
all potential warning signs that something's not right with our vents.
Exactly. And if you notice any of these red flags, don't hesitate to call a qualified professional to inspect your system.
Right.
It's always better to err on the side of caution when it comes to potential fire hazards.
I think you've officially convinced me to schedule a vent inspection.
Good. And remember, regular maintenance is just as important as proper installation.
Right.
Inspect your vents periodically for any signs of damage, blockage, or deterioration.
Okay.
A little preventative maintenance can go a long way.
So keep those vents clean, clear, and properly installed.
Exactly. It's all about peace of mind and safety when it comes to these often overlooked but essential systems.
This has been incredibly insightful. I feel like I've gone from knowing next to nothing about vents to having a much better understanding of how they work, why they're important, how to keep them safe.
That's what we aim for,
Wow.
to empower you with the knowledge you need to make informed decisions about your home and your safety.
But before we wrap up this deep dive, I have one last question for you.
Okay.
We've talked a lot about the technical aspects of venting,
Yeah.
but have you ever considered the environmental impact of all the hot air being exhausted from these appliances? Like, it seems like we're constantly pumping hot air out of our homes, especially with dryers. Is there a way to be more mindful of that?
Yeah. You know, that's a great point. We often overlook the energy waste associated with venting systems. All that heated air represents energy we've paid for just disappearing into the atmosphere.
So what can we do about it?
Well, there's a few things to consider. First, make sure your dryer is operating efficiently.
Okay.
A clogged vent will force the dryer to work harder,
Right.
using more energy and producing more hot exhaust.
So regular cleaning is key then. What else can we do?
Think about the type of dryer you're using.
Right.
Heat pump dryers, for instance, are much more energy efficient than traditional vented dryers.
Okay.
They use a closed loop system to recirculate heat so they don't exhaust as much hot air.
I've heard of those,
Yeah.
but they seem a bit more expensive up front.
Yeah, they can be, but the energy savings over time can offset that initial cost.
Okay.
Plus, some utility companies offer rebates for energy-efficient appliances.
Good to know. Are there any simpler, low-tech solutions?
Absolutely. Line drying clothes whenever possible is a fantastic way to reduce energy use and minimize your environmental impact.
Now, this whole draft thing, the NFPA 211 hammers on about it, but it can sound kind of technical. How would you explain it, like practically?
Okay. Imagine a river, right? Carrying all this debris downstream.
Okay, I'm with you.
A good, strong flow takes everything away, nice and efficient. Draft is kind of like that river, carrying smoke and gases up and out of your chimney. And just like a river needs a good slope, draft relies on pressure differences.
So the hotter the fire, the stronger that flow of smoke up the chimney.
Exactly. Hot fire means lower pressure in the firebox, drawing in that fresh air, pulling that smoke upward.
Makes sense.
And you know what? Chapter 11 really stresses good construction.
Right.
That's what ensures a strong, consistent draft. Keeps things safe and burning like they should.
Okay, now this is where it gets cool. The NFPA 211, it's got this rule about the throat of a masonry fireplace, that narrow bit above the firebox. It has to be at least 8 inches above the fireplace opening. Why so specific? What's the deal with that?
Think of it like a bottleneck, but in a good way.
The good bottleneck. Okay.
Yeah, that 8-inch height. It speeds up the smoke as it goes up, kind of creates a barrier so it doesn't, like, billow back into the room.
So it forces it upwards.
Right.
And this is why chimney sweeps put in those smoke guards, right?
Yeah, exactly.
Like another layer of defense.
Right. It reinforces that upward flow. Working with that 8-inch throat height, smoke goes where it's supposed to go.
It's all about managing that airflow. And speaking of the NFPA 211, it really dives into the smoke chamber, the area above the throat. You ever heard of parging a smoke chamber?
Oh, yeah. Key technique.
Now I always thought it was just like a looks thing.
Mm.
Make it all smooth and pretty. But it's more than that, right?
Way more. Think about it this way. A smooth, aerodynamic car versus one all boxy and clunky. The smooth one cuts through the air, way less resistance.
Right.
Parged smoke chamber, same idea. Smooth airflow, better draft.
So all those little bumps and nooks in an unparged chamber, those actually mess with the flow.
Yep, can make the draft less efficient.
Could lead to like smoke coming back into the room or the fire not burning as well.
Exactly, all kinds of problems.
Now I see the NFPA 211 also talks about combustion air ducts. Are those like becoming the norm now?
They are getting more and more common, especially in newer homes, you know? Those ones built super airtight. So these ducts, they bring fresh air straight to the fire, kind of like giving it its own dedicated oxygen supply.
So a hotter fire, which then means...
Better draft, you got it.
I'm learning.
Combustion air ducts, they make sure the burn is hotter, more complete, because there's always enough oxygen for the fire to do its thing.
So it's all connected. A well-built fireplace makes sure that river of smoke flows up and out, smooth sailing.
You got it. And that's why understanding those like seemingly little details about construction, it can make a huge difference.
And speaking of details, there's a lot in the NFPA 211 about clearances. It's all about safety, obviously. But what are the key things someone should know?
It's all about keeping things safe around the fireplace, making sure there's enough space between the fireplace and, well, anything that could catch fire.
Right, like wood framing, furniture, even the mantle, right?
Exactly. Think about all that heat radiating from a fire. Chapter 11, it lays out these specific clearances, and it's all about preventing that heat from igniting nearby materials.
So are we talking inches? Feet? Like, what kind of distances are we looking at here?
It depends what's around the fireplace. Like for wood beams, anything built into the structure, those need at least 2 inches of clearance from the front and sides of a masonry fireplace.
Okay, 2 inches. But the back of the fireplace, that gets the most heat, right? Does that need more clearance?
You're thinking like a pro. Yeah, the back needs at least 4 inches of clearance. It's all about how the heat spreads. The sides are angled so it disperses more.
That makes sense. Okay, so those are for the fireplace itself. What about things like mantles or decorations? Those can get pretty close to the fire.
Good point. The NFPA 211 covers that too. Anything made of wood, like trim, mantles, can't be closer than 6 inches from the fireplace opening.
So even if my mantle is, say, stone, I still need that 6 inches. It's not just about if it's flammable or not.
Nope, it's the heat itself. And it's not just the sides either. Anything above the opening that could burn, like a wood beam, that needs to be at least 12 inches away if it sticks out more than 1.5 inches.
12 inches. That's more than I would guessed. Seems like the NFPA 211's playing it pretty safe.
Safety first. But there is some flexibility built in. Like the standard, it allows for smaller clearances if you take certain steps to, protect things.
Oh, so there are ways to work around those measurements,
No.
like special materials or something.
Not work around exactly, more like ways to deal with the heat. A common one is using a wall shield, a protector.
So like a sheet of metal between the fireplace and the wall.
Yeah, like that. It acts as a barrier, absorbs and spreads out some of the heat. That way you can have less clearance.
Makes sense. But I bet there are rules about what kind of metal you can use, not just anything from the garage, huh?
You know it. The NFPA 211's got specifics. For instance, one way they allow is 28 gauge sheet metal, and it has to be spaced 1 inch away from the wall.
Got it. But even with a protector, wouldn't the heat still build up behind it?
Great question. That's why airflow behind the protector is so important. Helps carry that heat away, keeps the protector itself from getting too hot.
So it's not just like slapping a piece of metal up there.
Yeah.
You got to think about air circulation behind it too.
Absolutely. The standard, it even suggests leaving some open edges for that circulation or using a special protector designed for ventilation.
Makes you think about all those like DIY fireplace makeovers you see online. People might not realize how much goes into making it safe.
Easy to get caught up in the looks, but safety's got to be number one.
Yeah.
If you're ever not sure about clearances or protectors, always a good idea to talk to a professional.
For sure. And speaking of professionals, the NFPA 211's pretty clear about inspections.
Oh yeah, whole chapter dedicated to it. They're key to making sure your fireplace is in good shape.
So it's not just a good idea. It's actually required by the standard. How often are we talking?
They recommend at least an annual inspection. Chimneys, fireplaces, vents, the whole works.
Once a year, yeah, that makes sense. But I imagine it should be a pro doing that, not just like a quick homeowner check.
Exactly. A qualified chimney sweep, they've got the knowledge to spot things most homeowners wouldn't even know to look for.
So what kind of things are they looking at?
They're checking for anything that could be, a safety hazard or make the fireplace less efficient. cracks in the masonry, blockages in the chimney, damage to the flue liner, even creosote buildup.
Creosote, that black terry stuff. I remember hearing that's super flammable.
It is. It's a byproduct of burning wood, and it can build up in the chimney, become a real fire hazard.
So those regular inspections, they're not just about smoke in a house. They're about preventing a whole chimney fire.
Exactly. And the NFPA 211, it goes even further, lays out different levels of inspections depending on the situation.
Like different levels of seriousness.
Yeah.
What would make you need a more in-depth inspection?
There's 3 levels, level Y, level 2, and level 3. Level 1, that's your basic yearly check, visual inspection of what they can easily access. Level 2, that's more in-depth. They often use a camera, one of those chimney cameras, to look inside the flue.
Oh yeah, I've seen those. Like a little robot explorer going up the chimney.
Exactly. Great for finding hidden problems. And then there's level 3, that's the most thorough.
When would you need that one?
Level 3 is usually for when there's already a known issue, or after something like a chimney fire or earthquake, anything that could have caused damage.
So the inspection level kind of matches how much risk there might be. But it sounds like the NFPA 211, they say at least that basic level I inspection every year, no matter what.
Yep. Best way to catch those little problems before they become big, expensive ones. Or dangerous ones.
We've covered so much. Draft, clearances, inspections. Amazing how much goes into having a safe and functional fireplace.
Right. And it's all thanks to the NFPA 211 standard. It's really the go-to for keeping your fireplace running smoothly and safely.
I'm definitely feeling way more than no.
Hmm.
And I bet our listener is too. Before we wrap up, though, I'm kind of curious about those combustion air ducts again. We were talking about how they can be like inside or outside the fireplace. What's the difference? Is one better?
Well, it depends on the fireplace and how your house is built. An outside air duct, that takes air straight from, outdoors. Bypasses the room completely.
So no worries about it, like fighting with the fire for air, messing with the pressure in the room.
Exactly. Super efficient, keeps that combustion air coming reliably. Now, an inside air duct, that pulls air from inside the house,
Oh, okay.
often from a crawl space or basement.
Is that as good as getting it from outside?
It can be, but you got to make sure there's enough air where it's coming from.
Yeah.
And the duct needs to be sealed up tight, insulated properly.
Insulated, what for?
Condensation. If that duct's running through a cold space, you can get condensation.
Right.
Leads to moisture problems, could even damage the duct.
Makes sense. So both types have their pluses and minuses. Best choice kind of depends on what you're working with.
Yep. And if you're not sure which one's right for you, best to talk to a pro.
Always good advice.
Mm,
Wow,
yeah.
we've really hit the highlights here. From like the science behind draft to all the details about clearances and inspections.
It's all connected.
Yeah, it's all about understanding those key things that make a fireplace, safe and efficient. We're talking masonry heaters, wood stoves, the whole shebang.
Those are pretty different beasts, though, aren't they?
True. Like masonry heaters, they're not your average fireplace insert.
Nope, not at all. NFPA 211 even splits them into 2 types, listed and unlisted.
Listed and unlisted, huh?
Hmm.
That rings a bell, but could you refresh my memory on that?
Sure. So think of a listed heater like it's been to school, got its degree from a lab, and has a detailed instruction manual.
So it's like pre-approved for safety.
Exactly. Unlisted heaters, though, they're more like self-taught, We rely on ASTM standards for those.
Interesting. So basically, whether it's listed or unlisted, follow guidelines, right? No shortcuts.
Absolutely. And a big part of that is understanding clearances, keeping those combustibles far away from the heat.
Makes sense. Don't want any accidental bonfires.
Nope. So we've got masonry heaters down. Now let's tackle Chapter 13, solid fuel-burning appliances.
Okay, that sounds like a pretty broad category.
It is. We're talking everything from wood stoves to boilers, even those old-school ranges.
Wow, a real mixed bag. Where do we even begin?
Well, first up is chimney connections and usage, and that's where it gets interesting.
Chimney connections. That seems pretty straightforward, doesn't it? Just connect it.
You'd think so, but NFPA 211 wants to make sure those connections are spot on and that they line up with what's in Chapter 9 all about chimneys.
Hold on, there's a whole chapter just for chimneys.
Oh yeah, they're kind of important. They're the heroes, venting out those hot gases, keeping things safe.
Okay, so it's not just connecting, it's connecting it, right?
Exactly, and that includes materials. NFPA 211 is picky about what you can and can't use.
Like, for instance?
Well, take galvanized steel. Seems like any metal pipe would do, right? But nope. Why not? That zinc coating, it reacts with the heat, and the stuff from combustion could be a real hazard.
Wow, so it's got to be the right material for the job.
You got it. And another thing, accessibility. Got to be able to get in there, inspect, and clean the chimney.
Yeah, that makes sense, but what if it's in a tight spot, hard to reach?
That's where good planning comes in. NFPA 211 wants those access points easy to get to for safety and convenience.
Like routine maintenance on a car, right? Got to check under the hood.
Perfect analogy. Speaking of which, let's talk wood stove inserts. Those are popular.
Yeah, they can really up the cozy factor of a fireplace.
For sure. And when it comes to their chimney connections, NFPA 211 has some specific things to say, especially about those liners.
Liners.
Yeah, you know how chimney sweeps always want to run those liners all the way to the top?
I always figured that was just to make cleaning easier.
It does help, but there's a bigger reason. It's about draft and creosote.
Okay, I'm listening.
So a smaller liner, it actually makes for a faster draft. Like the gases just shoot right up.
Really? That seems counterintuitive.
It is, but think of it like a river narrower channel means faster current.
Ah, makes sense. So less creosote buildup with those full-length liners.
Yeah.
Safer in the long run.
Exactly. It's a great example of how those code requirements, they're there for a reason.
This is really interesting. I'm starting to appreciate the science behind all this.
And we've only just begun with Chapter 13. There's still a lot more to uncover. It's kind of surprising, you know, how many people just don't think about installation when they get one of these appliances.
Yeah, it's easy to get caught up in, like, how it looks, the style and all.
Right, but safety first, always. That's what NFPA 211 is here for, making sure things are done right.
So when we talk about installation, what are some of the big things to keep in mind?
Well, first off, got to consider the floor. What kind of floor are we working with? Combustible or not?
Combustible, like wood floors and such, right? And non-combustible would be like tile or concrete.
Exactly, and that makes a big difference for how we approach protection. You wouldn't want to just plop a hot stove on a wood floor, would you?
No, that sounds like a bad idea.
That's why NFPA 211, it lays out all these guidelines, for making a safe buffer between the appliance and anything flammable.
So layers of protection, basically.
Think of it like building a fireproof platform. Could be concrete board or air spaces, maybe some metal sheeting. The goal is to keep that heat away from the wood.
Like wrapping the stove in a fire-resistant blanket.
I like that. And it's not just the floor either. Gotta make sure the appliance itself is well supported, nice and stable.
Solid legs, a good base, that sort of thing.
Yep. You don't want a wobbly stove, that's asking for trouble. Could damage the appliance too.
Makes sense. What about those non-combustible floors, though? Are we good to go there, or...?
Well, the risk is lower, for sure. But NFPA 211 still recommends taking precautions. Even concrete, it can crack under high heat if you're not careful.
So better safe than, even with those tough floors. I've heard about those listed floor protectors. Do those come into play here?
They do. They're kind of like pre-made protection, tested and certified, ready to go under those appliances.
Like a fire safety shield, all ready to go. So no matter what kind of floor, support and protection are key. Anything else we got to keep in mind for installation?
Well, there's clearances. Can't forget about those.
Ah, yes, those invisible boundaries, keeping the flames at bay.
That's the one. NFPA 211, it dedicates a whole section to this, telling you exactly how far away those hot appliances need to be from anything that could catch fire.
No hugging the fireplace, I guess. But how do they figure out those clearances? Is there like a formula or something?
There's actually a table for that, Table 13.6.2.1. It lists out all the specific clearances based on the appliance, what it's made of, how it vents, the whole 9 yards.
So different appliances, different distances. Makes sense. But what if, say, I need a 3-foot clearance and I just don't have the space? Am I out of luck?
Not necessarily. There are ways to, reduce those clearances safely. NFPA 211 allows for that.
Oh, really? Tell me more about these clearance reduction tricks.
It's all about creating thermal barriers and good airflow. For example, you could use something like brick or tile, as a shield. That can help reduce the clearance needed.
So building a little mini fortress around the stove.
That's a good way to think about it. And if you want something a little easier, there are also pre-made protection products, panels and shields and things that are already tested and certified for this.
Wow, so many options.
Right. And to help you visualize it all, NFPA 211 has some great diagrams. Figure 13.6.2.1, they show you exactly how it all works.
So kind of like a blueprint for fire safety. NFPA 211 really goes all out to keep these appliances in check, huh?
It does, and that's why it's so important for everyone. Homeowners, installers, inspectors, these guidelines, they really help prevent those terrible fires.
Well said. Okay, so we talked about installations, materials, clearances. Anything else we should cover before we wrap up? Chapter 13.
Wow, we've really covered a lot of ground today, haven't we? Masonry heaters, solid fuel-burning appliances. Yeah, it's been a whirlwind tour. Chimney connections, as clearances, installation, the whole shebang.
And you know what? I got to say, I've learned a ton. I had no idea like how much actually goes into making sure these systems are safe and efficient.
It's a whole science, isn't it?
Yeah.
It really shows you like how important these standards are and how much work goes into them.
Speaking of standards, any final thoughts before we wrap up our deep dive into chapters 12 and 13?
I think the biggest thing to remember is that like NFPA 211, it's not static.
Yeah.
It changes, as we learn more, as technology changes.
So it's not enough to just like read it once and be done, right?
Exactly. Got to stay updated.
Yeah.
Check the latest edition, keep up with industry news, maybe even take a class or two.
So this deep dive, it's been a great start, but the learning never really ends, huh?
That's the truth. The more you know, the safer you are, right?
Absolutely. Well, I think it's time to let our listeners go and process all this great info we've shared today.
Yeah. Thanks for joining us on this deep dive. Hope you found it, I don't know, interesting, maybe even a little fun.
Stay warm out there, everyone. And until next time, keep those fires burning safely.